So now that we've talked about Java futures, what the concepts are, how to visualize them, how to program with them, let's talk about their pros and cons. So what are the pros? So one thing you can do with a future is you can potentially leverage parallelism more effectively while still keeping a small number of threads. And you do that by being able to use a pool of threads, either a fixed pool or a variable pool or a work stealing pool or whatnot. Here we're going to use a variable sized pool of threads, but the same concept applies with a fixed size pool of threads. In this particular case, we're going to be searching for the musical notes, do, re, mi, fa, sol, la, ti, do, in some input. And we're going to submit something to search for a word in the input. And as you can see, that will go and be given to the executor completion service, which we'll talk about later briefly because it's not part of this course. And that will go ahead and add the task to the queue of things to be processed asynchronously. And then we can automatically tune the number of threads because this is a cached thread pool that has a variable number of threads. So it'll tune itself automatically like an automatic guitar tuner. And then the results can ultimately be taken from the queue of completed futures. So again, this is a little bit outside the scope of this class, but there's a take method that can be called on the executor completion service, which will block until there's something to be processed. Once there is something to be processed, take removes it from this thing called the completion queue, and then we can get the results by calling get. Get will not block. Take might block if there's nothing in the queue, the completion queue. Other things you can do with with regular futures, non-completable futures, is you can block until the results are available, if you so desire, by calling get, or you can poll or timed wait. And this is typically done, you typically use this polling or blocking, timed blocking feature to make sure your program doesn't sit there wedged, blocking, waiting for something that will either take a really long time to finish or may never finish if something goes out to lunch and it goes into an infinite loop or the server never responds or whatnot. You can also cancel something and test to see if something's been canceled, so you can see if it's done. If it's not done, you can see if it's been canceled. If it's not canceled, you can cancel it. And that may also make your program more responsive, especially if your user decides they're sick of waiting and they want to shut things down, they can cancel the futures. There are downsides, of course, which of course is also what motivates the need for completable futures. The first issue is there's a very limited feature set. So you've only got these 5 methods or so that you can do on futures. You cannot explicitly complete futures. You have to use additional classes and other mechanisms like future task, which are kind of cool, but they're confusing and a little tricky to use properly. They're usually hidden from you by frameworks where you submit tasks, but under the hood there's a future task that's used. Another big deficiency with Java futures is they cannot be chained together fluently. In other words, you can't have dependent actions that are triggered as the results of earlier asynchronous processing. It ends up just being a very awkward programming model. You also cannot have these things triggered reactively. You have to either do timed waiting or polling or blocking, even worse. And that's almost always the wrong thing to do. It's like open mouth, insert foot. You have to write code that relies on timing of the future results. You're probably asking for trouble down the road. And another big problem you have with futures, because of the limitations with the feature set, you can't efficiently wait for a collection of futures without doing a lot of extra things and a lot of extra programming. So in this particular case, as an example, we submit 2 futures, and we don't know the order in which they're going to complete, but we have to decide the order in which to wait for them. So it might be that F2 finishes before F1, but because of the way things work in futures, we have to wait for one to finish before the next. So whatever order we wait for them, that puts you into this Procrustean bed of ordering, which may in fact not be as efficient as you might like. In general, it's awkward and inefficient to try to compose a bunch of futures together in some kind of a pipeline. It just doesn't work very well, and it's inefficient. Of course, because of those deficiencies, that motivated the need for the Java completable futures framework, which is what we're going to talk about next. So all this introductory stuff, which I tried to go through as quickly as I could, was really just there to set the stage for why we had to do something better. And the something better is substantially cooler, but as you will see, with coolness comes more complexity and more programming effort to get it right. So as usual, that's kind of a double-edged sword that we have to be aware of. So that's the end of the pros and cons of Java Futures.